All right, welcome to today's webinar on Simplify Mainframe Integration with AWS, where we're going to dig in a little bit deeper to how VirtualZ enables some of the Amazon services storage from the mainframe side. I'm Dustin Froyam, one of the co-founders, and I work on the Global Alliances function for VirtualZ. And I have Vince Ray, my co-presenter today, who's co-founder and our CTO. Thanks for joining us, Vince.
Yeah, no, happy to be here. It should be a good session.
So we're going to talk about a few different integration points. So one, how to get mainframe data out to AWS, both into databases, data lakes, in an easy fashion using PropelZ. We'll talk a little bit about storage and kind of our unique offering in this space. And that'll cover Zaac, but we'll also talk about some use cases for PropelZ there. And then around accessing real-time mainframe data from AWS. And that can be to a data lake or for some AI purposes, but also for application migration and modernization. And we'll go specifically into a particular use case there. So Vince, let's start with PropelZ and a little bit about our architecture, and then, how do we integrate with specifically RDS, but also then, we can integrate with Snowflake on AWS or Databricks or any other data lake that's available on AWS. Can you kind of talk us through that in a high level?
Yeah, well, so at the core, PropelZ is a way to get mainframe data, VSAM files, sequential files, tape data sets, GDGs, pretty much anything you might have on your mainframe. And the typical use case is we take that data, transform it to a more kind of platform neutral format, in other words, rows and columns, and we store the result in pretty much any target database that has a JDBC connection. And you list some of them here. And in fact, Amazon RDS has been a wonderful asset for us as we develop the code. That's actually where we do substantial portion of our testing. So we'll stand up all of the different databases, take our mainframe data, push it into that environment, and what you see that might have originally been a really complicated, let's say a VSAM file, you'll see it's just simple rows and columns in a database, really wherever you want it to be. Certainly it could be RDS, it could be Aurora, it could be those kinds of managed database services, but it can actually also be just about anything you might stand up. You might go out to let's say an EC2 environment, stand up a big Linux server and install just about any database you might want inside that server image. We can certainly work with that too. So one of the keys here is we're talking directly to the target database, so that makes it fast. That makes it super high performance. It's not like some of the other solutions we look at where there are middle tiers involved, where you take your mainframe data, put it somewhere else, then you have another application that operates against the data and figures out how to get it into the target database. In our case, we go straight to the target database and skip all of that intermediate node stuff. So it's fast. It's single pass through the data. Doesn't require read the data once on the mainframe, write it somewhere else, read it again to process it, write it to it's one single pass through the data. Another important thing is that usually when you're dealing with mainframe data, you're dealing with complex data of different types. It might even be just text data, but typically text data on the mainframe is going to be EBCDIC encoded. It's not going to be ASCII or UTF-8 or any of that. But even more importantly than that, a lot of times if we pick up, typical, let's say a VSAM file, I'll use that as my example probably through most of the presentation today. We look at the records within that file. Very frequently, they're going to be a mix of different data types, a little bit text, a little bit of, I don't know, maybe floating point, maybe packed decimal, maybe, all sorts of binary fields. I mean, all sorts of things that are pretty common to mainframe applications. The problem is a lot of those formats are kind of unusual once you get away from the mainframe. So what we do is we allow you to give us a little bit of metadata. And when I say metadata, really what I mean is something like a COBOL copybook that describes the records. And then we can use that information to understand, oh, there's a text field, a packed decimal field, whatever the format of the data is. And then that gives us enough information to kind of transform that data into what the underlying target database supports. So a text field, and if you're going to, I don't know, MySQL or Oracle, or that might become a character field in the database. Might get stored in that database as Unicode, or whatever you've got that set up to. Same thing for all the other data types I've mentioned. You can store really just about any type of data you want there. And one of the cool things about the way PropelZ works is that this mapping that I'm talking about between the types that we understand on the mainframe side and the types that are available to you in the database, that's open. You can tell us, use whatever you want to use. Maybe you want your, I don't know, big character data stored as blobs. That's a possibility. Maybe you want it as fixed length character. Maybe you want it as variable length character. Maybe you want different encodings. I mean, all of that's possible through transformation. And the result is that after you run PropelZ, you go look at the target database, and you don't just see, bit for bit what was on that VSAM file. I mean, we can give you that if you want that, but you generally will see that data broken down into its specific columns, and then meaningful results for all of the comments that way. So that is probably where most customers who try to do this manually, that's where they spend their time. I mean, Dusty, you and I have talked to customers that tell us it can take them weeks to
Yeah.
look at an arbitrary file and understand what all the data types are, and all of those other things in there. So we by automating that and driving the whole thing in a declarative way. In other words, you're using metadata that tells us what the data looks like. I mean, you could do that in 5 minutes in typical case. That's not weeks and weeks. And again, because it's direct connection to the target database. And mostly we're talking mainframe customers here, so we're probably talking sites that have lots of bandwidth and all of that. I mean, it really just screams over the wire. In our test environment, I'll share that our mainframe is the smallest possible mainframe you could imagine. And the target we use, actually, it's an Amazon RDS running in free tier at Amazon. So it's a tiny little target, and we still get anywhere from 6 to 10,000 rows per second. And these are big rows. These are the records we tend to test with are about 1K long. You can see what I'm talking about online, Dusty. I'm sure you'll have the links later on to all the demos and all. But we would expect typical large mainframe customer to be able to do this at very high performance. The other thing too is that, I mean, we're talking about specific targets here, but the reality is we can talk to anything where there's a JDBC driver. That's about 100 different types of databases. So if you have kind of an unusual requirement there, you want to go to, I don't know, Teradata, or you want to go to Ingress, or some of these less popular databases, as long as there's a JDBC connection, we can connect to it. And then, one of the other things that, we've done pretty recently is we've improved our ability to do incremental updates. Sometimes you've got source files that are just, terabytes long. And, maybe you need to capture what's changed every day in that file or set of files. You don't necessarily want to start over every day, though. So, we give you, really cool feature that'll look at the files that you're operating against and decide what's changed and only move the either newly inserted or changed records to the target. So, if you update, I don't know, 5% of the records on that file, you only need to move 5% of the data over the wire that way. There are actually a lot of ways this could be done. I mean, what I just described is kind of built in, and we like that for just arbitrary files. But sometimes there's a better way. Sometimes your file, maybe it's a VSAM keyed file, and the key has a timestamp in it or something like that. So that makes it really easy to say, PropelZ just position to current timestamp and just give me all the records since the last time I ran. We can certainly do that type of thing too. We can select records by subsets of the file. Either if it's a keyed VSAM file, we can use the key, position to a particular key and read this many records, or until you get to the next key, or until you hit the end of the file. If it's not a VSAM keyed file, you can do roughly the same thing with record numbers. Go to the millionth record and then read from there till the end of the file. And that sets up other ways of doing incremental processing. If you know the characteristics of your data, you can use those kinds of things too. You can also filter the records that you process. Sometimes, again, this is pretty common in mainframe. Sometimes your files will have many, let's call them record types. So there might be a value at some offset in the file that says, this is a type 1 record or a type 2 record, or whatever it happens to be. And all of those records might be different formats, except for the type. Now, normally, the way you'd want to deal with that is you'd probably want to create multiple database tables in the target. So, all of the type 1 records go into this table, all the type 2s go into this table. And again, they could all have different metadata, different fields within them. That type 1 record might be, let's say it's names and addresses. The type 2 record might be, I don't know, transactions, product names and prices and all that stuff. So, all of that is possible with PropelZ. Or you might just use the filtering to do masking of the data. I don't want my target database to have certain things that maybe I feel are sensitive. So omit those records. So a lot of ability to do that sort of thing. PropelZ, a lot of times we work with customers that really what they have is a batch, maybe a production workload. They run a whole bunch of batch jobs and they get to the end of that, and that process created a bunch of files, and what they want to do now is upload one of those files to the target database. So that's what you're doing. That's really easy with PropelZ. You can run it with JCL. You can add a batch job step, or use your job scheduling software to trigger a new job when that's all done. And now you're just automatically keeping your most up-to-date information on whatever targets you want. You can also use PropelZ the other way. We include a command line version. So let's say sophisticated, relatively non-technical user, if he knows, here's the name of my let's say a VSAM file, and here's where I want it to go. He can run that interactively if he wants. And then despite the performance and the throughput, I should mention that virtually everything we do is zip eligible. So we're not using those expensive general purpose MIPS on your mainframe that are kind of driving all of your software costs higher. What we're doing is running PropelZ as a zip workload, and that means that it doesn't contribute to driving your software bills higher because usage is higher. The usage that PropelZ uses doesn't spin that software meter at all. Same as other zip workloads would be. So really simple to get going. Very, very flexible. Another feature I'll just mention very quickly. Sometimes we run into really large scale projects. We spoke to a customer that's trying to migrate potentially it's millions of files to databases in the cloud. And for those cases, PropelZ is an obvious thing to do. But the other capability we've added recently is we can run them in parallel. So you might run, let's say, I don't know, 10 copies of PropelZ concurrently. And then you can rip through, assuming you have the bandwidth for it, you can rip through millions of data sets in relatively short order that way, again, depending how much bandwidth you have. So and that applies, by the way. It might go the other way. It might be that you're one big data set, but you want a copy in Oracle, a copy in SQL Server, copy in God knows where else. So you can use our parallel features to do that kind of thing in one shot as well. So yeah, a lot there. Dusty, did I miss anything? Or?
Oh yeah, no, I think you covered it. I just wanted to highlight one of the things you did touch on is we're hearing this a lot. Uh, we're working with several customers that have either implemented, event-based or change data capture type architectures so that they can get intraday updates to their database or to their data lake or whatever platform they are. And those tend to be one, very expensive, somewhat fragile, and in many cases they've never even got them implemented and functioning. So after a year or two of trying to implement them, they're looking for an alternative solution, either because of the cost or the functionality. And, so Vince, with PropelZ, we're time to value in hours or days, not weeks, months, years. Is that right?
Yeah, and you bring up a really good point. I mean, if there are a few cases here. In a lot of cases, it's not like you're writing applications that need to read, let's say, a VSAM file and a copy of that record out of, let's say, an Oracle database, and they have to be guaranteed to be synchronized. There's no chance of reading, a record that may have been updated in one place, but not the other place yet. I mean, that's a hard problem. That's kind of like a distributed database problem where one of the data sources happens to be on the mainframe. Some of the change data capture solutions, that they aspire to solve that problem. In other words, let's say I have a mainframe transaction that updates a VSAM file. They get control and part of that update, and they'll communicate it out to, let's say, an Oracle database or in whatever type of database. And the idea is that that original VSAM update isn't considered complete until all of that update work has been done. So number one, that's a huge hit to performance for that poor transaction that just wanted to update the vsam file. It's got to wait for all of that stuff to happen. And if it doesn't wait for all of that stuff to happen, if you do that in an asynchronous way, then suddenly you can't guarantee that everything's in sync anymore. It might be that I update the vsam file and then I asynchronously update my target database, but what do you do if that update doesn't work for some reason? Now the Oracle database has one value, the vsam file has another value, and I don't even know that there's been a problem there. So for those kind of cases where, I'm using that replica of the data for, BI or analytics of some sort, or to drive an AI model, or, those kind of things where that data tends to be read only, that's an awesome amount of overhead to have to put up with in order to, just get a current copy of the record out to the target. The problem is even beyond what I'm describing, because often to get that change data capture, I have to do things like implement, vsam RLS with log streams and all sorts of other things that can drive the change data capture approach. So and as you said, and I think we've heard this enough now that uh, I could see if you really had that need for distributed transaction processing and you needed guaranteed integrity on all the records all the time, everywhere, then maybe you would go down that path. But for the majority of use cases where what you're looking to do is just have a near real-time copy of the record out on the target database, that's a lot of pain to go through. Much better alternative would be to run PropelZ with our incremental options. And, even if you want to run it every 30 seconds or something like that, we'll kind of find the change records and guarantee that they get to the target. It's not truly real time, but often applications can tolerate that, and you can save all of that burden and cost and ongoing operational care and feeding and everything else that goes into some of these change data capture approaches. So yeah, I'm agreeing with you, Dusty. I think that a lot of it, of course, it all starts with what are the requirements of the application. But in a lot of cases, those CDC approaches are, way, way overkill for what we're seeing today.
Just quickly mention, so Propel ships with our tested, validated, optimized driver for Oracle, SQL Server, Postgres, MySQL, plus Snowflake. If you want an additional tested, optimized JDBC driver that plugs into Propel's, depending on what it is, about $5,000 to $10,000. So it's not a huge uplift. And PropelZ is just $50,000 per year, unlimited data, unlimited instances. So extremely cost-effective solution. All right, Vince, let's move on to storage integration to AWS with Zaac. And maybe you can kind of highlight some of I know we really like Elastic Block Storage. But also, we integrate with NFS-based storage and S3-based storage. Can you maybe talk a little bit about those use cases as well when you're talking about Zaac here?
Yeah, so Zaac is, a different paradigm than what we've been talking about so far. It's not replication of the data. It's the idea that what we're going to do is spin up, virtual disk or virtual tape in really wherever we want. Some Amazon service really could be just about anywhere. And then we're going to make that cloud storage behave just like it were a local ZOS, disk or tape volume. So your application thinks it's reading and writing a vsam file that's just sitting on a normal mainframe disk. What it's really doing is reading and writing files that are part of a virtual disk image that's hosted in the cloud. Now, one of the cool things we do with this is that the protocol we use to talk to the target is relatively open in our case. We could show you how to write connectors to whatever cloud data source you wanted. But generally, they fall into three categories. I mean, you mentioned the NFS one. Really, what that means is that in Amazon terms, that would be uh, EFS, Elastic File System Operations. And what that does is, if you were to look at that target after we've run, you would see virtual disk images, very similar if you run, VMware or lots of the other virtualization technologies out there. They create a file that's a virtual disk image. Well, that's basically how Zaac works too, except Zaac is on COS. So, the idea is that you're free to create as many virtual disk or tape volumes as you want. Again, the idea that it's both tape and disk emulation in one product is really unique to us. Most of our competitors just go down the path of tape, but of course, that means you can have things like a vSAM data set in the cloud. You can have, let's say, I don't know, a DB2 table space in the cloud. You can have an IMS database in the cloud. We can allow for any of that. In fact, you could have, vendor products doing low-level physical EXCP IO operations against what they think is a mainframe disk, and that can also be backed by cloud storage. So, very open that way. And then, as I started to say, there are three common approaches. The file-based stuff is the NFS approach, and you'll see virtual disk images in your NFS target that way. One that we like primarily because of the amazing performance we can get out of it is the EBS approach and the block store approach. This is basically an iSCSI approach. So we address that target, not so much data set names and normal file operations, but by doing low-level iSCSI commands to it, which tend to be order of magnitude faster than a lot of the other ways that we can access the cloud storage. So that's number two. And then, the third way is, all of the cloud environments we support have, some type of object storage. It's typically API based. S3 is a great example. Glacier would be a great example. That's not really file systems. That's not really iSCSI, block-oriented I/O. That's API-oriented I/O, I guess I would call it. The advantage is it's really low cost, and it's probably more suited for certain things than others. If you're looking for true archival storage where you write your data, maybe it's a tape emulation instead of a disk emulation, and you're using it for archives, and you're going to write that data, and odds are good you're not going to touch it ever again. Then, certainly you might go with a lower cost solution. If you're looking for, oh my God, I ran out of storage on my mainframe and I need, a few hundred terabytes tomorrow, and it's got to be able to support vSAM and DB2 and all, you probably would lean much more towards EBS or EFS, depending what your needs are. One of the other, similar to what I mentioned for PropelZ, one of the other cool things that we do in Zaac is that we also enable, for instance, duplexing across multiple targets. So I can have a virtual disk image that looks like one disk on ZOS, but it's not just backed by, let's say one EBS volume on Amazon. It might be backed by one in, let's say the, Eastern zone, one in the Western zone, or really whatever makes sense to you, you can implement that way. Some sites might think about, well, I want my primary copy to be in Amazon, but for DR purposes, I want maybe an on-prem or Microsoft Azure or Google or Dropbox or whatever else makes sense to me. And all of those copies are perfectly fine with Zaac underneath. I'll point out that the level of features and security that you get and so forth. I mean, certainly ZOS is still doing all of its normal thing, so you don't get to, you as a user on the mainframe don't get to access a file without the mainframe security system agreeing to it. So, nothing there changes. As far as the security of that data in the cloud, that really is a function of what the cloud provider offers. Amazon offers lots of security. So if you wanted to do, let's say AWS encryption on the disks, you absolutely can do encryption on the disk. If you're using S3 and you want to do versioning and create multiple copies of that data, so I can, at any moment say, crap, something went wrong, take me back to the way this data looked last Tuesday at 3 o'clock in the afternoon, you can do that as well. So, all of the features are available to you depending on, what's in the cloud solution that you choose. And again, there are probably different trade-offs there in terms of price and performance and all of that. So, but you get to do that. One of the wonderful things about Zaac is, again, unlike a lot of our competitors, we don't have any code off of ZOS. Our product lives entirely on ZOS, and we talk directly to the target. That makes it much easier to support really anything we care to support. We don't have to go out and develop, an agent or whatever the terminology is that lives in the cloud, and then that has to exist everywhere we want to support. Our solution is, self-contained right on your mainframe.
Yeah, Vince, I'm hearing in the market much more often is about data resiliency too, right? So having using Zaac to either in disk mode or in tape mode to have, secondary, tertiary, even quaternary copies. And while we're talking about AWS here, really all of our products are cloud agnostic. So they may keep a something that's very um, very fast accessible in something like EBS, as you were mentioning, but then also a tertiary copy in Glacier, for long-term storage and archiving that, would really only be retrieved in emergencies, or even another copy in Azure or Google Cloud.
Yep.
So that's a very common one. I think the other feature that, really speaks to me from my history is, looking at very low recovery point objectives from a data standpoint, and what the journaling capability of Zaac does, not only for, kind of network resources, but really that RPO, having essentially a 0-second RPO. Vince, can you just talk really briefly about that and that uniqueness
Yeah.
of the market?
Yeah, no, that's an important thing to understand too. I mean, if you're going to trust cloud storage and your mainframe, it has to be really resilient in a lot of ways. It's not just duplexing and all of that. That's part of it. But what do you do if you have a little momentary glitch in the network, and you lose connectivity to the cloud for a few seconds at a time, or whatever the details are. So we I'm going to brag about this a little bit. It's a patented approach that we've taken here. And what we have done is, some of you may be familiar with the idea of journaling file systems. And, this is something you'll find, on a lot of different platforms. And the idea is that you kind of separate the data from changes to the data. The changes to the data are the journal. And what that means is it makes recovery much simpler in a lot of cases. If I should lose a disk, for instance, I might recover the data, or in fact, the data might be on a RAID device somewhere, so I may have another copy of it somewhere that I can still access. And then recovery is really just a matter of playing those transactions that I've journaled back onto the device. So the Zaac file system structure leverages this idea, but what's unique to us is we don't do that journaling out in the cloud on the target. We do that journaling on the ZOS side. And the reason we do that is because ZOS offers some really, really robust services that allow us to log those changes in a sophisticated way, so that they're available even if a network connection should break. So right in the middle of updating, let's say a vSAM file that's in a virtual disk that's hosted out in the Amazon cloud, the network can fail. The updates are happening in an asynchronous way because of the journal that we got. So that just keeps right on running fine. And then when that connection is reestablished, we're able to go through the journal and apply those changes forward to bring the target back in sync. So what that means is, a couple of things. I mean, yes, from a reliability point of view, it's dramatically better, and it protects you from the kind of outages I'm describing. But it also radically improves performance, because what it allows us to do is, when a virtual disk or tape is updated, we don't have to wait for that data to get all the way to the target before we consider it complete. As soon as that data is captured in the journal, and again, the journal is, it's the same technology that, like, DB2 uses to journal updates to its internal databases and so forth. So we know, okay, that data is hardened. It exists either in a coupling facility store, on a disk, combination of all of the above. We know that that data is in multiple places at this point, and it's been hardened such that we're guaranteed that it can't be lost at this point. At that spot, we can allow the application that did the original write here to just keep right on running. It doesn't have to wait for that data to go all the way to the cloud and get updated in the Amazon environment. So we make those kind of updates asynchronous, and that has a pretty dramatic impact on overall system performance that way. The other thing too is, that's really only the journaling part. We also do, and that really helps you mostly on the updates. On the read side of the data, we do a very similar thing. We use the VLF components of ZOS. VLF is a virtual look-aside facility, and it's built-in ZOS componentry that does really sophisticated caching. So all of the data that we're reading on the read side, it goes through the ZOS cache mechanism. Guarantees that if we have the kind of application that's going to go read the same portion of the disk over and over and over and over again, it's probably one physical read to the cloud to bring that into the cache, and then the rest of the reads are satisfied by a memory copy of that data, so there's no more cloud I/O needed for that. And then if I turn around and update that, I can update it, make sure that update is hardened in the journal, and allow the application to go with no, so that update activity tends to be asynchronous as well. This together, what I'm describing, gives us really amazing performance on some of this. And again, there's no magic here. A lot's ultimately going to depend how much data, how much bandwidth you have, all of those kinds of things. But it's surprisingly practical in a lot of use cases, and for good reason. I mean, what I've just described is very similar to what you see on, let's say Windows and Linux platforms. If I'm running, let's say a big Linux server in my data center, and I need storage for, in an on-demand way. I need, a petabyte for a month. Uh, it's common. I just go to AWS, I buy however much storage I need, I configure it into my Linux system, I run for a month, and then I delete it all. People have been doing that for over a decade, maybe close to 2 decades in some environments. On other platforms, it's just the mainframe's never been able to participate in that. And that's what Zaac does. Zaac gives us a way to say all of those same options that people have really benefited from on Windows and Linux and all sorts of other platforms, are now possible on ZOS as well. So yeah, we're pretty confident that sites that are happy with that kind of thinking about on-demand cloud storage, they'll be happy with it on their mainframe as well.
Yeah, and of course, if you're if you have an Outpost instance on-prem too, this will work in the same way. So pretty cool.
Yeah.
I'm just going to mention very quickly, we talked a lot about PropelZ, but there is storage capabilities with PropelZ. If you think about it, both in the migration standpoint, so we see this a lot with legacy tape data, or even some data center moves, those types of things, to move that data to the cloud, either putting it out in rows and columns or storing it as a blob. And not only is it tape data, but we can do SMF data, DB2 logs, etc. So it's a pretty cool thing. PropelZ has a lot of flexibility as well for that price we were talking about. So Vince, let's just briefly talk about Lozen and accessing data securely from the cloud in a more discrete fashion, or if they need read-write capabilities.
Yeah, no, Lozen is kind of complementary to all of the things that we talked about so far. Lozen is it's kind of the inverse of Zaac. Instead of mainframe accessing cloud storage, it's applications that really could be anywhere, EC2 or really anywhere, accessing mainframe data. So and the reason this is important is a lot of times, I might have again, I'll use a vsam file as an example. I might have that vsam file living on my mainframe, and it's used by dozens of different applications, and maybe you want to make the decision to move some of those applications to a more modern platform, rewrite them, whatever it is. But historically, the problem there has been the data. What do you do to deal with that data, especially if it needs to be updated? You can go down that path that we talked about before with change data capture and ETL, and and these are hard things to make work, especially if you've got applications that kind of remain on your mainframe that need to update this data at the same time as applications on your in the cloud environment. So our answer to this is leave the data where it is and access it wherever you need to run your application. So stand up your application in the cloud, and then use Lozen to access the underlying vsam data. So what that gives you is the ability, now you don't really have to think about all those other applications that may be dependent on the data. Just leave them alone. Their data's not moving. You don't have to rethink any of that. They just continue doing what they're doing, but you get to pick and choose. Okay, what might I want to migrate away from the mainframe, or how else can I leverage that data in a important way to get some value out of it? It may not just be a migration. It's not, maybe you don't want to move the application. Maybe you're looking to do net new applications, but they need that mainframe data. So again, PropelZ is one way to do that if replication suits your needs, but Lozen is essentially that, but in real time. So when an application in the cloud, let's say reads a VSAM file, what it gets is the same thing it would get if that application were running natively on ZOS. And the important implication of that is that means that application in the cloud gets access to all of the VSAM functionality. So if I've got let's say I've got a COBOL program that I'm running today on my mainframe, and I understand that I can take that COBOL and rebuild it in one of the tools out there like Micro Focus, or I guess it's Rocket's enterprise server today. And, and that'll run the COBOL, but again, what do you do about the data? In our case, what you do is you run Lozen on the mainframe, and when that COBOL program runs in the cloud, it's got access to everything it had when it was running on COS. So if that logic of that program is open the VSAM file, go read a record by its key, update that record, insert another record in the middle of the file, delete, all of that's possible in Lozen. There's no change at all in functionality. And things like data security and management. I mean, a lot of mainframe folks we talk to get a little concerned when they start replicating data off to other platforms, because they understand that the security of that data and how it's managed and all of that, suddenly they're reliant on some other platform to do that properly. Lozen, that's not the case. Lozen is because your data stays right on the mainframe, it stays protected by whatever security product you got on ZOS. It's managed the same way, you back it up the same way. All the things about that data remain unchanged, except now you're able to access it where you want to access it. So, and again, a lot of folks will kind of ask questions about performance and latency and all of this kind of stuff. The important thing to remember is, just using that example I used before, if you didn't have Lozen and you were looking to move that COBOL program I described to another platform, you might be tempted to do, let's say, an ETL solution. So you take your VSAM file from the mainframe, you do whatever you need to do to it, and put it somewhere else in the network. And because it's volatile and changing. Sorry about that. I hit the mute button accidentally. I've got to stop doing the gestures while I'm talking, even though you guys can't see me. My hands are moving a million miles an hour. But yeah, even though that data hasn't necessarily changed, you're going to move all of it. You don't know what that COBOL program needs. It might need the first record. It might need the millionth record. It might need, God knows what it needs. So what do? You take that maybe multiple terabytes of data from your mainframe, you move it across the network, store it in the cloud, run the application against it, and maybe the application needs to update, I don't know, 1% of that file. It updates, and now you got the same problem in reverse. Now you've got, I got this changed file in the cloud somewhere that I've got to get back to my mainframe, and you probably don't know exactly what was changed, so you migrate all of that file. So by the time you're done, you've made maybe 4 or 5 passes through this, what potentially could be multi-terabyte file. Think about Lozen, though. Lozen, the data stays where it is. The program starts, opens the file, reads a few records. We're not transferring that whole file. We're just transferring the records that the program's asking for. And same thing on the update side. If it updates 1% of the records, we transfer 1% of the records. And to go even further, Lozen is based on kind of industry standard NFS protocols at the communication level. And one of the cool features you get there is client-side caching. So if I have the kind of thing where I'm running hundreds of, let's say batch processes, one after the next against that same file, what tends to happen is you read it once, or the records you need once, they tend to stay in the cache while all of that runs. And as they're updated, the updates get reflected back to the mainframe. So, bottom line on all of this is if we put a network monitor in place and count, you might only move 1% of the data with Lozen that you would move otherwise, and that's a really significant difference here. It means that things that otherwise wouldn't be practical suddenly can kind of fall within scope without having to do major rewrites or any of that stuff. The other thing too is that when we talked about PropelZ, I mentioned that the target's usually a database. So kind of the implication there is the way you interact with your data is with query language. You're doing SQL statements against your data. Lozen is a file system approach. So on the mainframe, if you did open, close, read, write, on distributed platforms, you're doing open, close, read, write. So, in that COBOL program I'm talking about, it's not like you have to sit down and look at it and say, well, it did this, this read over here with this key, so I need to translate that into a SQL select with a where. You don't have to do any of that. You just keep doing the same read you've always done. And, as your slide shows here, to make this as easy as possible, we've created a handful of connectors that just plug right into a lot of different environments. I mentioned Rocket's enterprise server product, the old Micro Focus environment. You can install the Lozen connector into that environment. And you don't have to know anything about Lozen. There's no proprietary APIs to call. There's nothing really at all you have to do other than recompile your program, make sure you have our file handler installed in that environment. Same thing for some of the other things you see on this slide. If you're believer in MuleSoft and you're writing data integration flows, and one of your flows happens to need a few records out of a VSAM file, we give you a connector right in that development environment. You drag it into your flow, set up a couple of parameters. Here's the data set I need to read, here's the records I want to read, all of that, and you're good to go. So we're a little different than a lot of vendors in this space. We don't say here's a set of proprietary APIs you have to learn. Our approach is it should be natural and easy in whatever environment you've got. And if it means, as you see here, we give you several different ways of doing roughly the same things, so that it's truly an out of the box, set it up, configure it, and you're processing mainframe data. That's kind of our goal. So anyway, Dusty, what did I miss that we should drill into?
Oh, that's great segue. So if you want to see Lozen with Rocket Enterprise Server on AWS in action, AWS is hosting a partner cast on March 25th. That's going to demo that and our integration with both AWS and Rocket Enterprise Server. We also have a demo on our website of this, but it's with a different application than what AWS is going to use. So you can see it in action in a couple different formats or use cases. There's also a AWS authored blog on the integration between AWS, Lozen, and you can find that at virtualzcomputing.com in our blog section. So it's a great kind of deeper dive into this use case as well. All right. Vince, I have a couple questions quickly. So On PropelZ, I know we talked a lot about VSAM, but can we source from like DB2 or IMS or something else like that? So into a different target other than a different source and a different target other than VSAM to a relational database or data lake.
Yeah, no, that's totally a great question. And what we've talked about so far is really just kind of the surface of what PropelZ can do. It turns out PropelZ is three parts. There's an input part, the transformation processing part in the middle, and then the output part. The most common configuration is what we talked about. The input part's a file of some sort, VSAM file, sequential file, whatever it is. And the output is a JDBC connector to that allows us to write to pretty much any database that supports JDBC. But those are completely customizable. So to your point, if I wanted to get some DB2 data, there's no reason in the world I couldn't run the IBM utility, do a query in batch, and then essentially pipe the output of that query into PropelZ as its input. It doesn't have to be a file. And again, that's super efficient. It's right in memory. It's not like you have to write it to a file and massage the file and then read that into PropelZ or any of that. It's, run your query and pipe the output into PropelZ. Same thing on, and that could be used for anything. I mean, any input that you can script that way can trigger PropelZ. It could be DB2, it could be IMS, it can be, one of the examples we talk about sometimes is we have an example of that listens for ZOS console messages and retrieves them as they're being written and sends them through PropelZ to whatever target you want. We can do the same thing for SMF data. A lot of customers tell us they spend a lot of time and money figuring out how to do secure kind of archives of their SMF. So you can use the SMF listener that we provide, captures the SMF data in real time, record by record as it's written, sends it through PropelZ, and PropelZ can store those SMF records as blobs in really whatever database you want them. So, the input is really open-ended that way. The output is really the same idea. I mean, it's, as I said, I described the JDBC approach, but, it turns out you can plug in anything you want to in that case. One of the examples might be you might have I don't know, a need to trigger a transaction. You don't want to write a database. You want to trigger a transaction through Kafka or MQ or whatever messaging protocol you want. So you run PropelZ. We read the input as we've been talking. We transform it. And maybe you want to even, you don't want to see those records as bit for bit what came off of some VSAM file somewhere. Maybe you want to see them as XML or JSON or CSV records. I mean, we do all of that, and then we can hand copies of those records to any process you want. So if you wanted to pipe that into a script that did a web service call, an HTTP transaction, an MQ update, a Kafka transaction, all of that's possible too. So it's really any input, the transformation processing we're talking about, and then any output that you care to have. Certainly file to a database is probably the most common. That's certainly what we had in mind when we did PropelZ, but it is completely open-ended that way.
All right, thanks, Vince. So if you're interested in any of these use cases, deeper dives. This is just a short list. There's actually a ton of content out there, but this is another series of webinars diving into these solutions. I can be found at our website. And we have a ton of other resources, blogs, the demos that I mentioned before, and then both our internal and external upcoming events, but also a lot of these other webinars that are available on demand. You can link off there, or you can get those directly on our YouTube channel. Well, thank you for joining us today, and thanks, Vince, for all your help through this webinar, and have a great rest of your day.
Thanks, guys.